Unreal Engine 5.5 introduces many awesome things to PCG, and one of them is grammar. Now, despite the name, grammar isn't something to do with the English language where you write essays now for PCG. What it is basically a very simplified syntax language that allows you to put symbols and words together to create what you need. So in this video, I'm going to be going through the sample project and then going over how everything's set up, why it is that way, and kind of breaking it down so it makes it a little more digestible so you guys can get started using grammar for yourselves. So let's get right into it. If you're a brand new project, you're going to need to go to Edit, Plugins, search Procedural, and make sure your Procedural Content Generation Framework PCG is turned on, and restart your engine as needed. Once you have restarted, we need to go to the sample project. Now, the easiest way to do it is to hit this search button right here and then search for PCG. This will bring up the Procedural Content Generation Framework PCG in your engine and plugin content. Now, if you don't see this, here in the top right under Settings, make sure you have engine and plugin content turned on. Assuming you do, you should see your Procedural Content Generation Framework PCG folder here. And then down below, there is sample content. In the sample content, we want to go inside of grammar, and then we will see this grammar sample level that we can go ahead and open up. And this is the sample level that comes with 5.5 to give us a better understanding of actual grammar. Now, we'll be going over these four right here. This last one, as you see by the name, is experimental, and honestly, it deserves a video all on its own, as it introduces grammar combined with geometry script. We'll go ahead and go over the basics of these three, then we'll cover the more advanced building generation here. So let's start with a spline slicer. As it says, useful to sample points along the spline with a very simple logic like door green with two modules C on both sides, and then fill the module fence red, which is what we see. We have the green door, the two modules to the sides, and everything else is a fence. And one thing you might notice is also in the exact middle of this spline. If I select the spline and just go ahead and move it somewhere else, it'll just adjust itself away from this point because this is the starting and end point. And the way I know this is the starting and end point is with this spline point selected. In the detail panel here, we can say select spline points. And if I click this button, select the first spline point, it selects this one. If I select something else and select the first one, it is this one. So that means that is the loop all around. And you can see that this always is in the middle of this spline. Now, how is this set up? Let's go to the PCG component in the detail panel, and let's open up the PCG graph to take a look. Right away, one thing you might notice is this is actually surprisingly very simple to do. So we're getting the spline data, as we would normally do, and then we're adding an attribute called grammar. Now, what is this attribute? So if you click anywhere else or select graph settings up top, you get access to the parameters. And here you can see we have a variable called grammar. If I open it, you can see it is a type string. So that's all the grammar is. It is just a string. And here we are specified the string for this grammar. So we're taking the grammar and we're adding it to the information of the string. Then we're using a subdivide spline to break it up. Now the subdivide spline node is something new in grammar now. What it takes is the actual spline information. And you can see in the detail panel, it has a module height. So we're setting it to be 100 units tall instead of the very thin spline that it was before. And then it has module information. So here, if I go ahead and open these up, you can see here's the fence of a size 100. Here's a door of a size 300. And here's C, size 50. So if you're wondering how is it that those different pieces are different lengths, this is where it's set. So this symbol we understand from grammar. And the reason we understand it from grammar is because down below here, we use grammar's attribute turned on. Now, to make sure that we have more information, there is this extra output attributes. If I open it up, you can see we have the symbol attribute name being symbol, the size attribute name being size, scalable attribute name being scalable, and the debug color attribute name being the debug color. Because we do have the debug colors here, you can see it is set to be red for the fences, green for the doors, and blue for C. And we go ahead and save that information and output it. So in a way, this already just splits up a spline into different side segments as well. If you wanted points to be specific sizes, and let's say you want a really long point and a really short point, a really long point and a really short point, one after the other, you could do that with grammar as you see here. Modifying the bounds, that gets us the little gaps in between here. And then for our own sake for the demo, they are taking the debug color and assigning it to the color and then debugging it. And that gets us the red, blue, and green here. So it makes sense how this is set up, but what does the grammar actually do? How does it work? So this is the grammar string that is there. Now, it might look intimidating first, but it's actually relatively simple. You can see the main things are in brackets here, C, fence, and door are all in these square brackets. And when you're using the square brackets in grammar, what that means is that is a sequence. So if you can have multiple things here, like I could put, say, fence, comma, door, and that will be then, it'll spawn a fence, and then we'll spawn a door specifically in that sequence when you use the square brackets. So in this case, it says, hey, spawn a fence, and then it has this asterisk. The asterisk basically says spawn as many fences as you can, whether it's 0 if you can't spawn any, or 1,000 if you can spawn more of them. Just continue to spawn them until you can't anymore. Then it says, okay, but make sure you can still spawn C twice. So it wants to spawn this sequence specifically 2 times, and then it wants to spawn a door, and then C twice again. And after that, again, put fences as many times as you can. So what ends up happening is this part here, we always want this. This will always happen. And we want fences to basically be at the start and end. Now, what this means is this will be in the middle of our spline because we have fences on the start and fences at the end. If, for example, I removed one of these fences, it will be actually at the end or at the start. So let me show you. If I select this grammar and we come here, and I go ahead and remove the fence with the asterisk at the end. I just delete it and leave it at C2 at the end and press enter. You can see that now our actual setup here has gone ahead and brought itself to put the points at the end. There's a door and the little 2 C extensions, and then the fences everywhere else. If I go ahead and put this back, and let's say I put it another one in here, I'll put fence asterisk, and press enter. Well, it has moved this a little bit further to the left, because effectively we're now saying, hey, there's 2 of these fence sections, and you know what? And there's only 1 here. So we've now put this basically a third of the way over. And if I add 1 more fence, you can see it is now moved over even more. So that is how you use those square brackets. It always goes in order. Now, because it's a sequence, this makes the sequence a little bit easier to read, but what you can absolutely do is do C, C, and then C, C here as well. Remove the 2s because those are needed. That's already doubled. And in fact, we can even cut all of this out and just say, hey, this module is just C, C, the door in the middle, and then C, C. If I take all this and paste it into our grammar script here, you'll see it is exactly in the same location. And we still have door in the middle, the 2 C modules, and then fence everywhere else. And if I wanted to, I could remove one of the C's entirely. And now one of them has only one of them. I'll go ahead and return it back to the original setup because this is all plugin content and I have not made a copy of it. I want to make sure that I don't save it, overwrite any of this, or it'll break things in the sample, and I'll leave it as clean as I want. So if I wanted to make changes and play around with it fully, I'd go ahead and make a copy of it for my own self and play within there to modify things and tweak things. But that is the spline slicer that is using brackets. Now, I specifically say brackets because this one here is using these curvy brackets, and this is a stochastic version. And you can see it has a module, it has a weight, another module, and a weight. And the stochastic version is the module fence with a probability of 2/3 with this, and C with a probability of 1/3. So if you can see here, in this one, we go ahead and just spawn randomly one or the other. And it's completely randomized between all of them. And if I go ahead and select it, it's like the PCG graph, and open it up, you can see it opens up to the exact same graph because it is the same one as the previous one. What's different is over here in the parameter overrides, the grammar is overridden, and it's now placed in this string. So we have these curly brackets at the start and the end. And what we learned from the previous one is we want to repeat this as many times as we can using the asterisk. And inside of it, we see fence 2, C1. That means the fences are 2 times more likely to appear than C. Now, we can go ahead and tweak this. We can make it the fences are 10 times more likely to appear by changing fence to 10. If I copy this into our grammar, press enter, you can see that the large red sections are, well, very common here, but occasionally you will still get a few smaller ones when they're able to appear. Now, if I was to set fence 10 and C5, it would be the similar as I was having C1 and fence 2, and so we effectively get back to the same thing we had before. Now, with this setup, if you have nothing here, it is assumed to be 1. So if I go ahead and set this back to something like this, without the :1, it'll still work. In fact, nothing has changed because it's still using the same seed, but I currently no longer have the :1 that was here. Because if you don't have anything specified, it assumes it is 1. Now, this does not take decimal points. You can put them in, it will not break, but it doesn't do anything. So for example, if I change this 2.9 instead of just 2 and pasted it in and pressed enter, you can see nothing has moved. But if I go ahead and change this to 3 and press enter, you can see it has recalculated it for a 3-to-1 ratio. So keep that in mind. Whole numbers only, even if you can type in a decimal. So that is the stochastic version, using these curly brackets. Again, curly brackets versus square brackets. And finally, we have the priority version. Now, this description is a little bit misleading, and I've confirmed with the person who created this map from Epic that it is just a typo that will be addressed in the actual full release of 5.5. But basically, right here, it says module 1 : priority 1. This priority is not a thing in the priority version. That's not how it works. So ignore the priority here. But as it says, it will try to place as many doors as possible, then fences, and finally C. And if I take a look at the grammar parameter that it has here, and again, this is a typo. This is not needed. In fact, I'm going to go ahead and remove these, not to confuse you. And if I put this back in exactly how it was and paste it in, press enter, nothing has changed. It was just a slight misunderstanding and it got propagated into the map. But one thing to notice is it has less than, greater than as its boundaries. And effectively, it goes left to right always. So first it spawns as many doors as it can, then as many fences, and then C, which is what we're seeing here. We're getting all of these doors, and then it has no more room to fit another door. So it puts a fence, which is a smaller piece, and then it puts the C module, which is smaller still, that can still fit in. So again, the syntax for this is using the less than or and greater than. And just like all the other ones, the asterisks mean it repeats this as much as it can. So it's putting as many doors as it can, then as many fences when you can't fit doors because doors are wider, then it does C. Now, at the current moment, there is no documentation written completely for grammar. That is why on the 5.5 roadmap for grammar, it has all the syntax written there. So if you need, go ahead and bookmark it. The link to it will be in the description below. And that way you'll always remember, hey, which syntax is for which type of grammar. And there is no project file this time, as this is available for everyone inside the sample project. But still, I want to thank my patrons who support me. Thank you guys so much. And if you'd like to join the community, the link to the Discord is down below as always. Thank you again to my patrons. Let's get back to it. Now let's go ahead and look at this more complicated building blueprint. Now, just like the other one, this is all based off of spline. As it says, it first uses the spline to generate a few floors, then for each floor, use some shape grammar to assign meshes. And with it selected, if I scroll down to PCG, you can see we have a few parameters here. We can debug the floors, debug the modules. We can also tell it to just not spawn meshes if we don't turn that off entirely. We also have the ability to change the building height. It's set to be, let's say, 1500. It'll spawn another floor. It's set to be 1000. It'll be less floors. But note that the sizes of these does not shrink and grow. The height of these modules is set in stone. So if I set this to be, let's say, 1050, we got an extra floor, but at 1060, nothing has changed. 1100, nothing has changed. Because based on the size of these modules, we cannot fit another one, and so it does not spawn anymore, despite our building height being higher. Then we have the module information, which if I open it up, we can see, well, C here is 100 units. There's the debug color. Then we have W, W1, and W2. Now, when looking at it from outside, the letters might not mean much, and really they don't need to be just letters or random words. You can make them, as the ones before, name specifically what it is. You can call it a door, a window, etc. So don't look at it and be like, oh my goodness, how am I going to remember what is C, what is W? It was just created for this demonstration using those, but that doesn't mean you have to do it that way as well. But if we want to, we can overwrite it here. And the last one is the mesh info, where we have an array of meshes here. So this is all great and all, but how is this set up? Well, if we go ahead and open up the graph, we get access to the full graph. And let's start at the beginning. So at the very beginning here, we have the spline data, and we're adding the building height as one of the attributes, and the attribute is called extrude vector. Now down below, we have a check. And then basically this is there, so if you want to have it be as part of a full graph, and it has an input node, and you plug something into that input, like a spline from somewhere else, it will use that instead. So it will check, does it have any data information? And if it does, if it's even has a single point, it has something, it'll be greater than 0, and so it will go ahead and use the input. Otherwise, in this demo, it goes ahead and uses this information here. After that, we go ahead and add an attribute. The output target is called grammar, the type is string, and the string value you see is main floor in brackets, intermediate asterisk, which is this right here. Now, as we've learned before, that means this is a sequence node. It will do this first, and then it will do this, and it will repeat intermediate as many times as it likes. And we can see that in this building. This first floor is different than all the floors after it. Now, to show you what happens, what if we wanted to have a different end floor? Well, let's, for example, take our main floor and copy it to the end here. So we'll do the main floor, which is the bottom floor. It will do all the middle floors, and then it'll have a different end floor that is the same as the bottom. So if I copy this and put that into a string value, and we take a look, you can see the bottom floor and the top floor are now the same. Because in this graph, we've told it to do the main floor, definitely, at the start and at the end, and in the middle, hey, if there's room, please put in as many intermediate floors as you can. Now, I'll go ahead and undo this, and we'll go back to the default as it was. I just want to show you how easy it is to go ahead and customize this with grammar to your needs. And the other thing to note here is, unlike previously, we're not adding it as a parameter. We're just adding it as an attribute with the output target called grammar, and it's a type string, as there is no type grammar, because it is just reading it from a string. It just understands what it is. From here, we do a duplicate cross sections. So if I press D to debug this, you can see the corners have gone ahead and been copied up. Now, to better explain this duplicate cross sections, let me debug this at attribute. You can see we're getting the 4 points of the spline as these large points here. And then if I debug the duplicate cross sections, where it has the extrude vector attribute as the extrude vector that we have created right over here based on our building height, it has gone ahead and changed the height of this to be the full size we've specified. But again, it is not fully exactly that height. It is as much as it can fit. Now, how does it do that? It is based on these module info section here. If I open both of these up, we can see we have the main floor and we have the intermediate. As you recall, in this previous one, we said main floor intermediate asterisk. Well, this is where we specify what that main floor is and what the intermediate floor is. So we say the main floor is a size 300. If I see this is a size 100, let's say, and I stop sampling it, and if we take a look, that bottom floor is now very short. It has adjusted it, and it has now fit more intermediate floors in here. And if I change this main floor to be 500, then I'll go ahead and scale it upwards. And again, these are now fitting less of them because the bottom one is significantly taller and has gone ahead and stretched it accordingly. So I'll return it back to 300 as it was, but this is where you can control that. And again, change the debug color if you'd wish to set it for later for checking which one is which. Now, just like in the previous sections, on the extra output attributes, we are exporting pretty much everything. The spline index attribute name is spline index. The symbol is the symbol. Size is size. Scalable attribute name is scalable, and the debug color is debug color. Everything is getting outputted, and it's stating to use grammar as an attribute with the grammar attribute called grammar. Now from here, we go ahead in 2 different locations. We go up to debug and down for the actual graph. I'll go ahead and cover the actual graph and how this is all working. So the first thing we do is reverse the spline. This is one of the new nodes, and you can see operation force clockwise, force counterclockwise, or just reverse. So when you create a spline, sometimes you'll go one direction or another direction, depending on how you've curved the spline. And this might be important when you create a mesh that has something different in the front and in the back. And depending on how you curved the spline, you might be looking at the back when you were supposed to be looking at the front. Now, one way to fix that is to flip the mesh, or another one is to reverse the direction of the curve. So you can see here, it is forcing it clockwise. After that, we're using a spline to segment node. It transforms the spline into points. We're extracting the angles, the connectivity info, and the clockwise info. We're not grading the tangents. That is not needed. Now, what does this do specifically? Well, if I select a reverse spline and press A to debug it, you can see here all the way on the right, we have the debug colors, the size, the scalable, and the spline index. And we have a bunch of points here, and it has all the information for each one. Here's spline index 1, spline index 3, etc. But we just get up to spline index. And if I go ahead and press A on spline to segment, we get a little more information. So I can now scroll to the right, and now we get the previous angle, the next angle, the segment previous index, segment next index, the current segment index, and whether it's clockwise or counterclockwise. Because again, we're extracting this information, and basically all of this information is being saved as an attribute. Then the next thing we're doing is setting the size.z, so we're using a set operation for an attribute, of the bounds max z, and we're getting it from the size z. Now the size z is not the original mesh's size, it is what we specified here in the duplicate cross sections. If I open our extra output attributes, the size attribute name is called size, and that's what we're getting. We've specified the size here, and so we're saving it as size. So we know that we've specified the size of the module, so we're saving it and making the bounds height of our modules to be that size. After that, we have a select grammar node. Now we're using a key as an attribute. In our case, our key attribute is called symbol. Again, going back to this duplicate cross sections, if I open it up, here's the symbol, intermediate. If I open up the extra attribute names, we can see the symbol attribute name is symbol. So now in the select grammar node, we want to compare the different symbols, which are these guys right here, the main floor and the intermediate, that are being saved as symbol attribute name symbol. And we want to check that the scaled local size in the x-axis, and we want to compare it against that. And the criteria is here. We go ahead and open it up. If the main floor scaled local size x is greater than 499, then we use this functionality. Otherwise, we have just the regular main floor with the regular select here. So if the main floor is not greater than 499, because it goes in order, then it just selects this one. Then we have intermediate. If the intermediate, again, scale local size in x is greater than 500, it does this. Otherwise, it does this. And again, we are outputting the grammar attribute. Now, what does all this mean? So the key attribute is symbol. So we're comparing it against the symbol here, which is again, main floor intermediate. That is why the key is called main floor. And we're comparing it in greater in scaled local size x. And scaled local size x is basically the length of the spline. So we see here that we have a window, a wall, a window, a wall. If I go ahead and make this considerably wider, you'll see it's still window, wall, etc. But if I make this considerably smaller, we just get wall. We no longer get window, wall. So after a certain size, it realizes, hey, I need to use the other method. And that's what the greater than check is doing. And you can see the ones up above no longer are placing in that middle circle window. They're just using the regular windows. And if I bring it back, you can see we get it back as well. Now here is also where you specify the grammar being used, right? In this case, we're using CWW1C, but that is actually set up later down the line in this next node. And this is the actual module selection using the grammar. So if we select it, we again have the subdivide segment. The subdivision axis is X because it is going along the spline. That is where it's being cut. And the attribute names for the model info again is being outputted, including the scalable and the debug color. And we're also outputting extra size, scalable, and debug color here. And we're using grammar as an attribute, and the attribute name is grammar. Now currently they have the actual mesh info all coming from just an array, and they have the module info also all coming just from an array where we have the information where it's the C is 100 and the debug color. And because these two are exactly the same length, we go ahead and add all the mesh info to the module info, and then they're using a subgraph to extract the mesh information. It is grabbing the mesh attribute name of mesh and is going to rename it and do quite a bit of extra little stuff here that we're not going to go in depth on. You can check it out here yourself to basically extract the mesh from the information. But as it says here, this could come from a data table. It also come from a data asset. There's many ways of doing this. But the main thing is all that mesh information gets piped into the module's information, because here we have the module info as input. If we uncheck this, this is where you would specify all of the meshes and all of the module information here. But because it's used as an input, we just grab it from the information we had previously. After that, we have the post-processing. This is to basically fit the mesh to the correct information of the bounds that we've specified, so it fits in the area because we need to scale it, rotate it, etc. So first we use our match and set attributes. The input attribute is symbol. The match attribute is also symbol, and we're keeping unmatched. So basically any information that matches between the two, it goes ahead and combines them. But if nothing is matches, then we still keep that information. After that, we divide, multiply, rotate, and offset our pivot to basically set up the meshes to fit inside of those bounds. And lastly, we just check, hey, do we have the spawn meshes bool turned on? If we do, then go ahead and spawn the meshes. Now in the static mesh spawner here, the mesh selector type is by attribute, and the attribute name is mesh. Now hopefully this has helped you kind of understand PCG grammar a lot more. This is just the very beginning of it. We're going to have a lot more, I'm sure, going forward into the future. But despite it sounding very intimidating, it's actually quite straightforward to use. The main thing is you're probably going to need to check which syntax is which, especially starting out. But once you kind of understand it, you can go ahead and start utilizing it to get really complex and interesting designs for your PCG graphs. And 5.5 has many awesome things, including scriptable tools now working with PCG as well. If you missed that video and want to learn more about it, check out it right here, where we go ahead and introduced dynamic mesh creation all within PCG itself.